dimensional analysis or conversion of units. As I state here, it is one of the most important skills you learn in chemistry and other science classes. The reason why it's important is because science always has units, measurements, of course, that you have to conduct, and there are various measurements like volume, mass, temperature, so on and so forth. So it is important that you are able of converting from one unit to another and from one dimension to another. Now, to give you an analogy of this, imagine you're going to another country. Let's say you're going to Mexico and you have your currency, US dollars, and you have, in this case, let's say you have 52 US dollars. And you would like to know the equivalent amount in pesos, in Mexican pesos. So you're like, okay, not sure if it's spelled correctly, but that's just to get the idea. Now, in order for you to go from US dollars to pesos, you need a conversion factor to do your currency exchange. So just looked it up. I think US dollar is about, so $1 is 22 pesos. So this right here is what we call a conversion factor. And it's important that you cannot actually go from US dollars to pesos. So in this case, in order for you to go from the dollars to the pesos, you need to find a way to input this conversion factor. Just erase this so that the US dollars would cancel out. Now, so if you're starting with US dollars, then they have to actually be in the denominator. So in this case, we have $1 here. And then 22 pesos will be in the numerator. And the reason why is because the US dollars, the unit will cancel out. So now you're going to multiply 52 by 22, and then you end with pesos. So in this case, this comes out to obviously a large number, but it depends on, again, it all depends on what are you converting here. So this comes out to be 1,144 pesos. Now, the idea of dimensional analysis is you always start with a given unit. And you would like to end with what we call a desired unit. So the given unit, whatever the conversion factor is, the given unit will go in the denominator to cancel out, and the desired unit will go in the numerator, because that's what you will end with. So again, the given unit is going to cancel out, and then the desired unit, that is what you're going to end with. Now, you can have more than one conversion factor. So you actually have to go through another conversion factor, and you will see these as we go. But again, this is the conceptual framework. Now, you might question, why do we have to do that since we have computers that do all of that and everything is converted and nice for us? And that's absolutely true. I'm not so much, or teachers are just not so much interested in you just being able to Again, you know, what is pounds in kilograms and so on and so forth. It's you learning the skill. Remember, a lot of this class is built on you learning the skills that you need in problem solving. So yes, you can have a computer or a software that spits that out for you. This is how many pounds I have. How many kilograms is that, for, say, for medical reasons? Well, you can do that. But again, you going through it is important. So let's go to the first problem we have here. Now, be aware that when you do these conversion factors, some you will have to know like these, and others will be given like in the second problem. So let's start with the first problem. This is a metric to metric. So here it says convert 2.8 kilograms to milligrams. Now, you need to be able, for the metric prefixes, this is a prefix, the kilo and the milli. You need to remember what they stand for. Okay, so if you go back to this table right here, kilo is 10 to the third, and milli is 10 to the negative third. So this has to be memorized, really. And you have to know this, not only for this class, but just think about it. It makes no sense that someone who's a doctor not knowing what a milli is, okay? Or a nurse not knowing what a kilo is. It's 1,000 grams, for example. So again, or micro, or someone a chemist, or someone as an engineer. So these are very important because they are the foundation. The metric system is the foundation for measurement purposes in the sciences and medicine. So let's go back to our here. So we know that 1 kilogram, so we're going to write these on the side. Kilo stands for 10 to the third, or 1,000. And we know that 1 milligram is 10 to the negative third. Now, some instructors may actually switch these out. So they may say 1 gram is 1,000, or 10 to the third milligram, because it's the opposite. But again, I like to use it this way because it just keeps it the way it is, rather than just going through another step. But feel free to do the opposite, which is 1 gram is 1,000 milligrams. But we're going to focus on this one. So let's start. We have 2.8, that's our given unit, kilograms. And I always like to say, okay, I'm going to leave enough space. Even if you leave more than enough, it's okay. And I'm going to say, I'm going to end with, it says clearly to me, milligrams. I'm going to end with milligrams. Now I have to figure out what's going to go next. What's my second conversion factor? I have 2 here. So that means I have to put these 2 in between. So in this case, what should I start with? Well, if I have kilograms here, then clearly I have to start with the first one. So if kilograms is what I'm starting with, that should go on the bottom. And I copy this number 1, and 10 to the third grams, or 1,000 grams, goes in the numerator. So now we notice that the kilograms cancels out, and now you're left with grams. But you're not done, because remember, you have to go to milligrams. So what I like to do next is, if I use a conversion factor, I like to cross it out. That way I don't have to use it again. So now I go to the next, and obviously all I have is this. So if I have grams now here, remember I need to get rid of it. Grams should be in the denominator in the next conversion factor. So therefore, I'm going to take this number, 10 to the third, negative third grams, and then 1 milligram on the top. And once again, look at the grams, how they cancel out, and you're left with milligrams. Now you have to do this into your calculator. So if you have a graphing calculator, we're not gonna so much focus on how to do the math because that is expected at this point of view. But if you go into your calculator, obviously 2.8 times 1,000, or you can just open parentheses and put 10 exponent exp or EE or caret to the 10 to the third, and then divided by 10 exp EE or caret to the negative third. If you know a little bit of math, this 10 to the negative third, you can actually invert that. So it's going to become 10 to the third on the top, or you can just, again, plug this into your calculator. So if you do this calculation, and if you would like to pause and do it so you can see if it matches this number. You should be able to get, one second. So you should be able to get 2. Or let's actually just write the full number, 2,800,000 milligrams, which in scientific notation, if you were to do this, you would get 2.8 times 10. If you count how many numbers are after the 2, where you put the decimal, that would be 1, 2, 3, 4, 5, 6 to the 6. So that would be your answer.